So we don't have to worry about trying to solve or change it. And right now, the b value is a half, or 3/2, not 1/2, it's 3/2. So if we're trying to graph a y-intercept, because that's really how we start graphing, and the y-intercept is -3/2. How would you graph that? How do you graph a y-intercept that's a fraction? Alyssa, would you know how to graph a y-intercept that's a fraction? What's something you could do with it?
I just like I turned it into a mixed number
Okay.
just for so it'd be easier for me, and I got 1.5.
Yeah, 1.5, or you can just make it into a decimal as well. So she said she made it easier for her by turning it into a mixed number. It's 1.5 as a -1.5 is a mixed number. Or make it a decimal. So you need something that's easier to graph than thinking about it as a fraction. Now, -3/2 is a pretty nice fraction, but maybe it's going to be one that's a little messier. So turn it into a decimal so that you have an idea where to graph it. So -1/2 is in between -1 and -2. And then we're applying the slope. So when we apply the slope is -3/1. So now all my points are going to be in between the boxes instead of in a corner of a box. That's okay. So we're supposed to go down 3 and over 1, because that's a slope, rise over run. In this case, we're falling. Well, if I go down 3, I'm off my grid, which is okay. I can make an extra line. So I'm going to go down 3 and over 1. And again, it's not going to be in the corner of a box. Or I could go the opposite. I could go up 3 and I could go backwards 1, and that's still negative as well. So up 3 and backwards 1. And again, it's going to be in the middle of the box because the y-intercept was in the middle of a box. So connect your points. And then you have a line. So graphing a fractional y-intercept just means making it a decimal. It's not going to be in the corner in an exact point. It might be somewhere in the middle of our box or our grid. Any questions with 20? All right, so looking at 26, this was a commonly asked question. So 26, we have 3x plus 7y minus 4 equals 0. And this one looks a little fuzzy, and I apologize for that. That's just the copying machine as it was scanning it. So here I see that, we have 3, 7, and 4, and none of those are divisible by each other. They don't reduce nicely. And this is also very close to being in standard form. So I'm going to rewrite this. We talked about two forms, slope-intercept form and standard form. I'm going to rewrite this one in standard form. In my mind, because 3, 7, and 4 have no common factors, there's not a nice number that they would all divide into. One of them doesn't divide into the other. I'm going to use the x and the y-intercept approach to graph this instead of trying to solve it for y equals mx plus b. So I'm going to find the x-intercept, and then I will find the y-intercept. So this is the other approach. You don't always have to get something in y equals form, and I think you guys are just so trained in your mind that you have to get it in y equals form to graph it, but you don't. So if I want to find an x-intercept, Ava M, how would I find an x-intercept? What do we have to do?
You have to plug 0 in for y.
Yeah, so 3x, 7 times 0 equals 4. And then when I divide, I get x equals 4/3. Yes, it's a fraction. There's no way around not getting fractions in this problem. I can think of that as a decimal. 4/3 is really 1 1/3, 1.3 repeating, and then write it as an ordered pair. So it's a point on the graph. So Ava M, if I want to get a y-intercept, what do we do to get a y-intercept?
You plug 0 in for x.
So now x is 0. Again, 3 times 0 cancels out. That's the nice thing about finding a y-intercept. I would divide by 7 and I get y equals 4/7. Can anybody tell me approximately what is 4/7 as a decimal? So that I have a better idea as to how to graph it. Ava, I'm going to pick on you one more time and then I'll be done, I promise. What's 4/7 as a decimal?
Hold on, I don't have it.
Does anybody have a calculator around?
I got it if you want me to say it.
Yeah, thank you, Ava. That sounds great. Thank you.
So
Ava,
it's like a
help me
long
together.
one.
Say it
Do
again.
you, it's like long. Do you like to round it to the hundredth?
Two decimal places. Hundredths is fine. Yes.
Okay, so 0.57.
Thank you. 0.57. All right, so when we go to graph this, the x-intercept is at 1.3. Again, you're approximating here. I'm going a little bit beyond 1. The y-intercept is at 0.57, a little bit more than a half. That's all you need to graph a line. You just need 2 points. So when I have an x and a y-intercept, it's just one way of graphing a line. I don't have to have slope. I can still graph a line using those two intercept values. Questions? So that was a different approach to graphing it, not always in y equals mx plus b form. So 26 kind of takes us into the word problem that was assigned, one of the two word problems. And this is talking about depreciation. If something depreciates, what does that mean? Brooke, do you know if something depreciates? What does it usually mean if something depreciates?
Does it mean like it loses value after time?
Yeah, do you know, can you think of like some kind of object that would lose value after time that you would buy?
Maybe like electronics?
Yeah, any
Because it
type of
gets older?
electronic. Yeah. So a fancy TV, your phone, whether it's an iPhone or a Samsung. Some of you might eventually get a car and that car depreciates in value. So there are a lot of things that depreciate. They go down, they lose value after time. So this is talking about a linear depreciation, which means it consistently loses the same value after every year. So when it's linear, it's the same amount every year that it's losing value. A business purchased a piece of equipment for $500,000. The value is represented by V of the equipment after T years is given by the equation 3V plus $250,000 equals $1,500,000. For 28, it says find the intercepts of the model, and then it says what does the t-intercept represent? And in the next half of this chapter, we're going to look at a lot of linear equations and really be interpreting what they mean. So part of going above and beyond is understanding what the problem is talking about and what the pieces of the problem mean, not just being able to do the problem. So we're going above and beyond it. Can we figure out what they represent? So we're asked to find the intercepts. Well, the intercepts are the variables in the equation. We just found the intercepts above for the x and the y-intercept, but now we have the variables v and t. So I'm just going to set it up as the v-intercept and then the t-intercept. And Ava helped us out with the last one, and if we follow what she did, so to find an x-intercept, we let the y equal 0. Well, if I have a v and a t, and if I want to find the v-intercept, I might as well let the other variable equal 0. And you need a calculator. So we have 3v plus 250,000 t, which I need to make that 0. And then that equals 1,500,000. So I know that my t variable is gone. And now I have 3v equals 1,500,000. So if I divide that by 3, somebody with a calculator, what is 1.5 million divided by 3? Or maybe you don't need a calculator and you can do that mentally. That would be awesome too.
500,000.
Yeah, thank you. So one of my intercepts is 500,000. So that's the V value. The value when T is 0. So the value of my equipment is 500,000 when I buy it. That's what that means. When I buy the equipment, it's worth $500,000. So if I do the same thing for the other one, now I'm plugging a 0 in for V. Which means this goes away. I missed my T variable. So I am taking 250,000. I'm going to divide that into 1.5 million because I want to figure out T. So what's 1.5 million divided by 250,000? So we can figure out our T variable or our T intercept.
6.
All right. So now it says, what does that mean? So this ordered pair would be 0, 6. So I plugged a 0 in for V, I got a T of 6. So those are the two intercepts. What does the T intercept represent? What does it mean in the problem? What's T talking about? Jaden, do you think you could take a shot at this? What's that 6 represent in this problem?
Oh, sorry. No, the T represents like the number of years the equipment will take to be worth no value anymore.
Yeah. So she said the number of years the equipment would not be worth a value. So after 6 years, there is no value left in our equipment. So again, that represents time. After 6 years, the value of the equipment would be $0. So it's not worth any, or it doesn't have any value after 6 years. Questions? On the flip side, the x-intercept would be the initial value of the equipment, which is what they tell us that you purchased it for. So your purchase amount is your initial value and time is 0. So both of those parts answer question 28. We're going to also do 29, and I'm going to come down at the bottom and look at 29. It wants us to find the slope. So we have 3v one more. Okay, so this is saying find the slope of the equation. So it's, in a sense, we need to kind of get this to look like y equals mx plus b, except we have a v and a t instead of an x and a y. Can somebody tell me what to do first for this problem? So what do you think you would do first? Kaylee, what do you think you'd do first?
To get v by itself, you need to divide the numbers by 3.
Yeah, and why do you want to get v by itself?
Because that would be the y equals.
Yeah, so that's your y. Time is always your independent variable. Each year that goes by, the value decreases. So things depend on time. So the time is really our x variable. So I'm going to just put in parentheses x, just to remind you. So anytime you see different letters, if time is in it, time is the independent. As time passes, things go down. The value of it goes down. So we are going to get the v by itself by subtracting the 2,500, and then we'll divide by 3. So the value would be, I can just keep this as an exact number. I don't think it divides. So now I have my slope and the y-intercept. The y-intercept we've already found, so it's just kind of solidifying that fact that they told us it was an initial value of $500,000. We also found that algebraically, the initial value being the $500,000. Questions? So the slope in this problem is that negative $250,000 over 3. What does the slope mean? Kaylee, you were the one that helped us start off this problem. Can you tell me what the slope means?
The slope represents the, no, I was wrong. I'm not sure.
Okay. Anybody know what this means? So we know that it's going down because it's negative. Brooke, what does it mean?
Was it like the decrease, like the amount it decreases every year?
Yeah. So this is saying that over 3 years, it's going to decrease $250,000. If we got this into a decimal value, then I can find out the exact amount that it decreases every single year. But this is showing you the amount that it's going to decrease over time. Questions? So as I said, at the end of this week on Friday and the beginning half of next week, we're going to be looking at equations and really starting to interpret all the parts of the equation and what it means. And we're talking about linear equations because once we get the linear part done, then we'll really start taking the graph and the functions and changing them. But this is just interpreting what parts of the equation represent with respect of some type of application problem. And that's the going above and beyond, not just being able to do the problem, but understanding what it means. And like in life, being able to understand what things represent, like that's going to take you further on life, not just being able to do the problem. Questions? So today we're going to see if we can try and write some equations. So when you're given information, can we try and create our own equation? And tomorrow we'll look at the application part of it. So today is more of understanding it. Tomorrow we'll apply. In your packet, if you can turn to sections 2-4. And this is page 15 in the packet, section 2-4. And our goal really is to write linear equations. So write equations of line depending on the information that you're given. And the first term here you have is point slope form. And point slope form is one way that you can write an equation of a line. When you're given a point and a slope, hence the word point slope form. I think point slope form is the least common form that's used, but it's actually really easy to use. So point slope form is the other form that we can use to have an equation of a line. There's a little chart below, and in this chart you see 3 different cases of information. So the first case is if you're given a slope and a y-intercept. So if I'm given the slope m, the y-intercept b, I would want to use slope-intercept form because I have that information and I can just plug it in for M and B. Point-slope form is useful when you're given the slope and a point that would be on our line. And if you look at point-slope form, there are two different y's and x's happening here. The y and x without the subscript, without the 1 attached to it. Those are our main variables in the problem. They are going to remain in the problem. The others are independent or dependent variable. The x and the y represent the point that we would insert into that equation so that I can find an equation that matches the line with the given slope and point. So again, the y and the x are our standard variables. We're not going to do anything with them. The y1 and the x1 is where we use the ordered pair. My third option that I could have, so we could be given information that gives you the slope and the y-intercept, that gives you a slope and a point, or my third option, I could be given 2 points in a line and be asked to create an equation based off of the 2 points on that line. So in order to do that, it says first use the slope formula, so that's like step 1. You pretty much need to know slope in order to write an equation of any line. If I don't know the slope, I have to find the slope. So step 1, if I know 2 points, but I don't know the slope, we're going to have to be able to calculate the slope. Just a reminder, that slope formula we talked about last Thursday, y2 minus y1, x2 minus x1. So I have to calculate that first. And then, after I calculate the slope, we would use point-slope form and either one of the given points to create the equation of a line. So I am going to use point-slope form today so that you can see how point-slope form works. My hope is that you always don't just revert to y equals mx plus b form, and that you try and use the other form to see how it really could be beneficial when you're trying to solve a problem. So the first example says write an equation when you're given the slope and the y-intercept. So if I look at my little chart, I have 3 options, and that's option number 1. I'm given the slope and the y-intercept. So if I have a slope and I have a y-intercept, it's saying we might as well just use y equals mx plus b because we don't have to calculate anything. I have all the information I need. So can somebody write an equation when the slope is 1/2 and the b value is 5? What would that equation look like? Jaden, what would that equation look like?
It would be y equals 1/2 x plus 5.
Excellent. Can you do the next one too, Jaden?
Yeah, it would be y equals -3/8 x minus 2.
Perfect. So all we're doing there is we're literally taking the slope and the y-intercept, replacing them in the equation. If you look at part C, this is a 3-part question here. Part C gives you a graph. Now, just because it's a graph doesn't mean that it's hard to do or hard to write an equation. Remember, we need to know the slope and we need to know the y-intercept in order to write the equation. So if I'm looking at this graph, can anybody tell me what the y-intercept of the graph is? Faith, what's the y-intercept of this graph?
1.
Yeah, wherever the graph crosses the y-axis. Well, that's at 1. Faith, if you look at the graph, how can you determine the slope when you have a line? Using the picture, how can we find the slope?
You can do rise over run.
Yeah, you can do rise over run. So if you look on your line, find another place that it crosses through the corner of a box. Now remember, a graph moves from left to right. So if I'm starting at the y-intercept that they give us, she said rise over run. So in this case, we're actually falling, we're not rising, but we're going down 3, down means negative, and then right 2. So you're counting how far down and how far to the right you're moving to get to the next point. That's what slope is. So now I can write the equation. We know the slope by counting. We have the y-intercept by looking at the graph. So negative 3 halves x plus 1. Questions? So that's just writing an equation in slope-intercept form because we're given the slope and the y-intercept. Even though we have a graph, we're still really given that information. We don't have to really do a lot of calculating. So the second example that we're going to look at says write an equation when you're given the slope and a point. So if I go to my little table up here, if we're given the slope and a point, we are going to try and use point-slope form because the point and the slope are already in this form of the equation. So let's see if we can kind of start with it. We're going to start out slow here. So it says take y minus y1, m, and then in parentheses, x minus x1. It says our line passes through the point 2, 1 and has a slope of 2. So the slope is the m in the equation. The 2, 1 represents the x1, y1 in the equation. So I'm going to take my equation and replace the variables that I'm given. So again, I'm going to find the m value and replace it with a 2 because it says the slope is 2. I'm going to replace x1 with its number, which is also 2, because that's the x value of the point that they're given. And then we're going to replace y1 with the y value, which is a 1. So I took the 3 pieces of the equation, the y1, the x1, and the slope, and I'm replacing those parts with the information that's given. Remember, x and y, that's part of our standard equation form, so I need to keep the regular x and y. So now we're going to simplify this a little bit because we're not going to leave it like this. We're going to try and get y by itself. So what could you do to simplify this equation? Madison, how could we simplify this equation so that we can get y by itself?
I would start by adding 1 to the 2 on the other side of the equation.
Okay, so I'm going to put it back here. So add 1. Those cancel. So now we have the 2 in front. It's being multiplied by x minus 2. And then I'm going to place that 1 in the back. And the reason I'm placing it in the back because it's a quantity that's being added or subtracted separate from those parentheses. What else could we do?
Then you could do 2 times x and 2 times negative 2.
Yeah. So that's 2x minus 4 plus 1. And then finally, Madison, what's your equation look like?
Then you would get y equals 2x minus 3.
Nice job. So now I have an equation of a line using point-slope form by plugging in that ordered pair for x1 and y1. So see if you can do part B. It's the same type of question. Try it on your own. So use point-slope form. Maybe you remember using this. Probably didn't use it quite as much as using y equals mx plus b form, but in this equation, there's literally a place for us to put all of those points or all the information that we're given, the data that we're given. And if it helps you to label the pieces, then you can do that as well, label those parts. There's a little trick in this question. Be really careful when you're plugging in a -1. Notice the equation says y minus y1, but you're plugging in a -1. So just be careful with that on the left-hand side. So that's what it really looks like. Y minus -1 turns into a big plus sign. And then also be careful when you're distributing the -1/2 to the -8. That becomes a +4. Lacey, what kind of equation do you have?
Like the answer?
Yeah, what do you have for your answer?
I got y equals 1/2 x plus 3.
Yeah.
Or negative 1/2 x.
Perfect. Negative 1/2 x plus 3. Any questions? Okay, so those would be two problems when you're given a point and a slope and we're trying to write the equation of a line. And we use point slope form. So the next pair of problems are pretty much an extension on that problem, except now we don't know the slope. So we have a value at negative 820 and then another point at negative 615. Our goal is to write an equation of a line that passes through these 2 points. So if I could graph these and look at the graph, what would the equation be that corresponds with the graph? How would you start this problem? What do you need to find first? So if you need to, maybe you need to flip back and look at that little chart, thinking about what information you're given and how to approach that problem.
Would you need to find the slope first?
Yeah, Gabby, nice job. So Gabby, can you plug the information into this slope formula?
Yes. So it'd be m equals 15 minus 20 over negative 6, and then that would change into a plus 8.
Perfect. What is 15 minus 20?
Negative 5.
And then on the bottom would be a
2.
2. Nice. Very good. So now we have the slope is negative 5 over 2. And I know you're going, wah, wah, fraction. They're not going to go away. They will continue to build. We will always have fractions. Even in life, you're going to have fractions. So we know the slope. The second part it says is to pick one of these points. And it doesn't matter which one. Either given point. And we're going to plug it into the point slope form. So pick a point. It doesn't matter which one you use. If you want to just stick with the first one because it's written first, that's 1. Or that's fine. So point slope form. Just because there's a fraction doesn't mean you can't do it. And actually, it means that it might work out okay as well. So if we plug in the 20, plugging in the negative 5 halves, and again, watch this negative 8, it turns into a plus 8. Remember, when you multiply fractions, you're multiplying the top. So I'm doing negative 5 times 8. You divide by the denominator. A fraction bar is really a division sign. So I divide by 2 in this problem. So negative 5 times 8 is negative 40. Divided by 2 makes negative 20. Fractions don't have to be difficult. It's like a mental thing. You're psyching yourself out because you see a fraction. So multiply the numerator, divide by the denominator. That's how fractions work. So negative 5 times 8 divided by 2. So Zach, what's the answer to this equation? What's our equation become if we simplify this?
Hello, can you hear me?
So what's the equation become, Zach? Getting y by itself. So if I add 20 to both sides, my 20s end up canceling on both sides, and we just have negative 5 halves x. That's it. That's our equation. So there is about a minute left. Before you leave or before you check out, I want you to make sure you're working through B here. So doing one more problem. So you might need a calculator because there's some decimals. If you're given a decimal, it's okay for your answer to be a decimal. So just try and work through this problem. By finding the slope first, use your calculator if you need some help, and then getting the equation of a line. So your homework this evening is exactly like these problems that we just went over. Yes, there may be fractions in the problem. You could have decimals as well, and there's going to be some with just nice integers, but it's going to be going over those 3 different steps. So the 3 different ways you can kind of approach in a problem, depending on the information that you're given. Try and use slope, point slope form. Don't always rely on slope intercept form. Does anyone have questions? All right, so happy Monday. Have a great day. We'll see you tomorrow morning. If you do have a question, today's Monday. So we've got math help at the end of the day, 3:10 till 3:20. Just pop on. The Zoom link is in this week's lessons. So you can feel free to just join and we will be here. Have a great day.
Thank you.
You're welcome. See you later.